Hello everyone and welcome to Cruel Karnaugh map tutorial. This is, as you can see, a much harder version of normal Karnaugh map, and this is a tutorial for those who are supposed to know how normal Karnaugh map works, because otherwise you wouldn't understand anything. So let's start with the easier example, this one. So what I'm going to do is, for my own convenience, take a screenshot and paint on the grid whenever I need it. So the way 5x5 kernel, 8x8, but it has six. It has 6, as you can see, variables. Assuming you know how the normal Karnaugh map works, each cell in the grid has its own 6 variables from 1 to 6, and they are either true or false. And your goal is, as always, write here down the string that covers all ones but doesn't cover any zeros. But this time you're supposed to find the shortest solution possible, the length of which you can see on this red button. In our case, it's 11. It does not include pluses in your string. So let's start. This is an easier example because, from my own experience, examples with shorter strings are easier because you can just sort of find them without using any strategy, just by yourself. So on this first example, I'm going to do exactly that. But first, I'm going to explain how to actually cover a set. On the normal Karnaugh map, you only had like 4x4 grid, and you could just draw rectangles with lengths that are power of 2. So, for example, this one or this one. Here it does not work like that. Well, it does, but it's actually extended. Because of new variables, you can actually cover extra space on this grid. So, for example, if you take this rectangle by itself and nothing else, you would only have your common variables would be not 1, not 2, and not 4. But each variable has inverted version, which represents in some sort of symmetry. So for this exact rectangle, the symmetrical version for not 1 would be 1, which would be this rectangle. As you can see, this rectangle has all the same variables except for 1, which turned into not 1, which turned into 1. So if we look at just one particular cell, for example, this one, its symmetrical value for 1 would be this cell. Oh, sorry, not this cell. This cell. As you can see, this cell has all the same variables except for 1. The symmetrical value for 2 would be this cell. Symmetrical value for 3 would be this cell, and so on. 4, 5, 6 are somewhere along here, so it's going to be symmetrical 4 is here, symmetrical 5 is here, and symmetrical 6 is here. So knowing all of this, you could theoretically build very amazing shapes. For example, this plus this plus this, and this shape has common variables of not 3, not 4, and 6. And if you add this, which contains all the symmetrical cells to this shape that contain negative symmetrical value of well, not symmetrical, but the same value for which one it is, for wait, 6, yeah. So it now has sorry, not 6, it's 5, wait, it's 4, yeah, it's symmetrical 4. So now it has one less common variable, yeah, and only has 6 and not 3 as common variables. So essentially, the bigger the shape is, the less common variables it has, which is once again our goal, to have as less common variables as it is possible. So with that in mind, let's start finding. Remember, we can't have any zeros on our shapes, so let's start with the red color. Okay, first example, if I look at this one, I can build a shape like this, which covers these 3 ones. I can't extend this shape more. I can't extend it to shape like this because it would contain zeros. I can't cover this because it would also contain zeros, and I can't extend it to these two with these 2 long triangles or rectangles because it would also contain zeros. So technically, this is one of the possible variants that could be a part of our answer. So let's see which 3 variables does it have in common. It's 1, 3, and not 5. Yeah, let's see what else do we have. We could, so for the next shape, let's see. We have a big chunk of 1s in here. We could technically cover it like that, but that would include 2 zeros here and here. We actually have a little zeros on this side. So we could do, what could we do is this big square. And it has not 1, and on the left 5. And just like that, we already covered 7 1s. By the way, the total number of 1s is 10 at the moment. It might be changed later. Okay, next let's choose blue. So we have a 1 left in here and 2 in here. So in order to cover this one, we could just use this rectangle, for example, but the smaller the rectangle is, once again, the more variables we have to use, which is bad. So let's try using more variables. We could try, I mean less variables. We could try this rectangle, which would give us 3 common variables. We could extend it like this, but this would cover a 0, so this is not the case. Let's try a different approach. Let's cover it like that, and like that. This is the same. This has the same surface as this long rectangle, so it doesn't actually matter because either way we don't cover any extra ones and don't cover zeros. So the length is still going to be 3 variables. But can we extend it longer? Yes, we can. We can also add this surface. It would actually reduce our swing by 1 variable. We can't extend it anymore, unfortunately. So let's see what common variables we have. Not 1 and not 6. So we already have 7 variables. We have 4 more variables and we only need to cover this shape. So we could just use 2 by 2 square and that's it. And that would be exactly 11 in length. So what do we have? 1, not 2, and 4, not 5. So let's input this into the module. 1, 3, not 5, not 1, 5, not 1, not 6, 1, not 2, 4, not 5. Awesome. Okay, let's try a long example, this one. Okay. So when you have when you supposedly have a long string, what I suggest to do is find ones that are adjacent to, well, not physically adjacent by, but adjacent by 1 variable, which was the thing I explained earlier. So, for example, this one. So let me finish my thought. Adjacent by as many zeros as possible. So this one, it is adjacent by, 1 second. It is adjacent by 3, the one that changes with this 0, because every other variable is the same within these two. It is adjacent by 5 with this 0, and it is adjacent by 4 with this 0. So that's great. We can mark these 3 cells, and we already know that we can't have, well, we can't cover a surface that would have a different that would have these variables that I mentioned different, because that would cover one of the zeros, which means these 3 variables I just mentioned have to be part for this one. So that would be so in pair with this 0 is going to be 3. In pair with this 0 is going to be 4. Keep in mind it's the one that has, it's the one that is on this one. So yeah, and with this 0 it's going to be 5. And like that, we only have 2 well, 3 variables left that we can test if we can actually cover with this one. The adjacents are going to be this one, and this one. Can we cover a rectangle like that? So yes, we can. This is the rectangle. I mean the surface. And as we established earlier, these are the 3 common variables. So I'm just going to conveniently remove all of this because it's going to be visual clutter, and just highlight. Well, unfortunately we didn't get rid of any extra ones, so we would need to work harder. So this is one of the 9, this is one down, 9 left. Okay, what else can we do? Let's look at this one. No, let's actually look at this one. It has 3 adjacent zeros, 1, 2, and 3. So what can we cover with this specific one? So the fact that this is adjacent to this 0 means that we cannot have vertical symmetry, so we can't have anything on the left side of the module. So this is out of table. The fact that this is paired with this 0 means we cannot have anything that is negative to opposite to 2, which is this surface, and the fact that we have this 0 which has opposite for 5. So this is -5, this is 5. So everything that is 5 cannot be covered. So this is out of table. So the remaining surface we can have is this and this. But there are 2 zeros in here actually. So we could cover either this or just this. Well, here is the dilemma. The first case has less common variables. Second case has more common variables. Well, because in the first case we have bigger surface. But in the second case we actually cover one extra one, which is actually bad for us because, well, that makes things harder to deduce. So I actually suggest remaining that fully, skipping this for now, but I'm just going to mark it down as a possibility. So it's going to be either not 4, not 5, 1, 2, or or 1, 2, not 3, not 5, not 6. And I'm just going to, okay, well, I can't get rid of this for now, but okay. I'm just going to mark this somehow. If later on we actually need this one to be covered in some very hard way, we can just return to this case and see if it helps. But for now, let's move to other ones. This one has this 0 and this 0 as neighbors. The remaining is fine. So let's see. So everything that is everything that is, well, it has -3, so everything that has +3 is going to be out of table for this one. So common variable will have to be not 3. So we can just remove everything that is 3. Next, we can remove everything that is, this 0. It's going to be everything that is +4, because this has -4 and this has 4. So let's remove that. negative. Oh, it's actually the entire bottom half. Okay. So it's also going to have -4. Okay, so what do we have left? We have this, this, and this left. Well, as you can see, here are zeros, so this is quite an obvious case. So this, this, and this are going to be our surface, which once again does not cover any extra ones, which is unfortunate. So let me remove this. Okay, -3, -4, and what else? Okay, -3, -4, and 6. Okay. Let me actually remove this. Okay, next. Okay, what do we have left? Okay, I can see quite an obvious. Okay, I'm going to take a risk and just select quite an obvious well, surface, if you can see what I mean. This and this, which will cover 3 ones at a time. I can't extend this shape because extending it from -1 to 1 would lead to, well, this 0 and a bunch of zeros here. Extending it by, well, from 6 to -6 would cover the entire left half, which also has zeros. So I'm just going to mark it for now as uncertain. But it's quite a nice shape, so I'm leaving it here. So what variables does it have in common? 6 and -1. Okay. Keep in mind, there is a possibility that these ones are going to be covered in some better way. So what we just did is just like waste of resources. Yeah, that's what I mean by uncertain. Okay, we have how many left do we have? We have 4 left. Well, including this one that is that spends one more variable for the green part. Okay, how many have we used at this point? So 3, 6, 8. At this point we've used 12 to 13. Okay, depending on the green part once again. Okay, so the remaining ones are all in here, which is a nice thing. We could technically try something like this and see if we can cover more. Extending this from -3 to 3 would also cover these 4 cells, which contains a 0, so that's a no. Extending to 5 would also cover from -5. Sorry, from no, never mind. From -6 to 6 would cover this rectangle, which also contains a 0, and extending from 2 to -2 would cover these 4 cells, which also contains 0. So for now I'm just going to write down this as a shape. So let's cover this. Okay, what 4 variables does it have in common? Not 1, 2. Wait, no. It's 2 and not 3. And 4 and not 6. So at this point we've used 16 to 17. Well, in this particular orange case, we also covered this cell, so we can just assume that we don't need this part, which actually makes it 16. So for this one, we can just use 4 variables. That should be great, yeah? That means 4 variables means the surface should only be 4 spaces, and I actually see it here. Let's use purple. This, 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 and this. Nice. So which variables do we have? 1, not 3. And along the left, 4, not 6. So let's count once again. 3, 7, 10, 12, 16, 20. Okay, let's input this into the module. Okay. 3, 4, 5. Not 4, 5, 1, 2. Not 3, not 4, 6, not 1, 6, 2, not 3, 4, not 6, 1, not 3, 4, not 6. Wait, what? Okay, let me just double check if my shape, if I just wrote down the variables correctly. So for the red shape it is 3, 4, 5. For green shape 1, 2, not 4 and not 5. Oops, okay. It's not 5, okay. Okay, this is the delete button, by the way. Okay, not 5, 1, 2. Not 3, not 4, 6. Not 1, 6. 2, not 3, 4, not 6. 1, not 3, 4, not 6. Okay, well, that's enough examples. You just need a little bit of practice with this because majority of the module is just improvisation. But anyway, thanks for watching and have a nice day.